In the first section of this chapter, we looked at what happens when we multiply powers. So we had the same base in two different terms. We multiplied those together, and we found that we add the exponents. Now we're going to be looking at quotients. So what happens when we divide one power by another and they have the same base? Well, look at the quotient 7 to the 5th divided by 7 squared. And we might want to write that as a fraction. So if we have 7 to the 5th over 7 squared, notice that we can rewrite that as 7 times 7 times 7 times 7 times 7 over 7 times 7. But we could take 2 of the 7's in the numerator and cancel those 2 that are in the denominator. And what we're left with will be 3 7's being multiplied together, or in other words, 7 cubed. And notice that once again we have a shortcut, but this time instead of adding the exponents, we're going to subtract. So we'll take the exponent in the numerator and subtract the exponent in the denominator. So in general, we'll have something that looks like this, where we have a to the mth over a to the nth is equal to a to the m minus n power. So we're subtracting here. Notice that a cannot be 0 because we're dividing by a to the nth power. And for now, we're going to say that m and n are positive integers, and we would like m to be greater than n. Later on, we'll find out that doesn't always have to be the case, but for now, we'll stick with that. We also could look at the power of a quotient property, which tells us, and by the way, that's an exponent there, it's not being multiplied by m. This is a over b, all raised to the nth power. So if you have a quotient that's being raised to an exponent, you can take the numerator and denominator individually to that exponent. So a to the mth over b to the mth. And notice that b cannot be 0 here because, again, we're dividing by b to the mth, and you cannot divide by 0. Okay, so let's look at some examples. And the directions tell us simplify the expression, write your answer using exponents. So here we have 3 to the 8th divided by 3 cubed. We have the same base, so we rewrite that 3, and then we subtract the exponents, 8 minus 3, and we end up with 3 to the 5th power. And that makes sense. You could take 3 of the 3's in the numerator and cancel out these in the denominator. You'd be left with 5 3's being multiplied together. Okay, number 2, we have a negative, but the same idea applies here. So we have negative 4. Again, please remember parentheses when they're required or when they're already included, divided by negative 4 squared is equal to negative 4 to the 3 minus 2 power, or in other words, negative 4 to the first power. Now normally, when you have something to the first power, of course, we don't even include the exponent. You could just write negative 4. But here, because the directions specified, write your answer using exponents, I'll go ahead and leave that there. Okay, number 3, here we have a quotient raised to the 3rd power. So that means we can take the numerator and apply the exponent, and the denominator and apply that exponent. Okay, and if we were asked to actually evaluate here, then we could figure out what is 3 to the 3rd power, what is 4 cubed, etc. But the directions again tell us to write your answer using exponents, so we're done. Okay, number 4, we have 8x to the 6th divided by 2x to the 4th. I'm going to rewrite that as a fraction, so 8x to the 6th over 2x to the 4th. And we can deal with the coefficients separately if you like. So that's 8 over 2 times, and then x, and subtract exponents. So 6 minus 4 will give us 8 divided by 2 is 4, and then x squared. Right, number 5, here we have 2 variables showing up in each term. That's okay. We'll deal with them one at a time. First of all, let's rewrite this in fraction form. So negative 6 h to the 9th k to the 8th divided by 3 h k squared. So first of all, deal with the coefficients. Negative 6 divided by 3, and then we have h to the n minus 1 power, 9 minus 1, and then k to the 8 minus 2 power. So this equals negative 6 divided by 3 is negative 2. By the way, if you have a case where the denominator won't divide evenly into the numerator, you can just go ahead and leave it as a fraction, just simplify it. So we have negative 2 h to the 8th power k to the 6th power. Okay, number 6. We have negative 3 divided by p to the 4th, all raised to the 3rd power. So we have negative 3 over p to the 4th. And we're going to take that whole thing and raise it to the 3rd power. So we can use the numerator, negative 3, raise that to the 3rd power. And we're also going to raise the denominator, p to the 4th, to the 3rd power. So here you have the power of powers property, and we multiply the exponents 4 times 3. So we end up with negative 3 to the 3rd power over p to the 12th. Okay, not so bad, right? On number 7, we have 2x to the 4th divided by y squared, all raised to the 3rd power. So this is equal to 2x to the 4th over y squared, all raised to the 3rd power. So in the numerator, I'm going to deal with that coefficient separately. So this is 2 cubed times, and then we have x. Again, we have to multiply the powers, 4 times 3. And then same thing in the denominator, multiply the powers, 2 times 3. So we end up with 2 to the 3rd power is 8. 2 times 2 is 4, times 2 again is 8. So 8x to the 12th over y to the 6th. And that's as much as we can simplify. Okay, number 8. The distance from the Earth to the Sun is roughly on the order of 10 to the 8th miles. Not exactly, but just in that neighborhood. The distance from the Earth to the Moon is roughly on the order of 10 to the 5th miles. Approximately how many times as far from the Earth is the Sun than the Moon is? And so here we would look at the distance from Earth to the Sun, 10 to the 8th. Compare that to distance from the Earth to the Moon, 10 to the 5th. And this will be 10, since we have that common base, 10 to the 8 minus 5 power, or in other words, 10 cubed. If you want, you could go ahead and say that 10 cubed is 1,000, or you could just leave it like that. And then we want to say that the Sun is approximately, so in the neighborhood, so it's approximately 10 to the 3rd times as far from the Earth, from the Earth as is the Moon. So however far the Moon is from the Earth, multiply that by 1,000 and you'll have approximately the distance from the Earth to the Sun. Alright, so there you go, and enjoy your quotient.